Hi guys, it is Thursday, unless you're doing this early. We are in a new packet now, okay? So this is your packet number 3. It's not the formative review, it's not the summative review, it's packet number 3, okay? So go ahead and get that out, and we are going to turn to page 58, okay? We're on page 58. Today is going to be a really short video, I'm hoping, because I know that my video from the other day, I think it was Monday, was rather long. So we're going to try to make this short. This is lesson 10.8 in the book. It's comparing and contrasting linear, exponential, and quadratic equations, okay? So this year we've covered these 3 types of graphs of functions. As you can see, this first one is linear, it's a straight line, okay? And our equation for a linear function or a linear equation is y equals mx plus b. You're very familiar with that one, okay? You should recognize this too. We did this a couple units ago, and that was your exponential function, okay? And that is y equals a times b to the x. That's supposed to be a b, not a 6b, okay? And then your final one, which you're really familiar with because that's all we've been doing the last month or so, is quadratics, okay? And that is y equals ax squared plus bx plus c, okay? So those are the 3, and so now we're going to talk about how we can tell the difference. Example 1, examine the ordered pairs and then determine whether the data represents a linear, exponential, or quadratic function. Explain your answer and then write the equation in appropriate form. Okay, so what I always do is I write these out as if they're in a table of values, okay? That's really going to help. Make sure they're in order. We've got -4 and 1/32. Got -2 and 1/8, 0 and 1/2, 2 and 2, and 4 and 8, okay? On the x side, you can see that we're adding 2 each time, okay? So just kind of look at the, let's see, what are we doing on the bottom? It looks like we are multiplying by 4, I would say, right? All the way across, okay? So we can see that we're going to have some kind of a common ratio, okay? So that should tell you that it's going to be exponential, okay? Now, the problem is we don't know what that common ratio is exactly because we're not going up by 1s. And remember, when we determine our common ratio, it has to be going up by 1s on the x. So we're going to go ahead and we're going to try to figure out what the common ratio is, which is our b, okay? So that's y equals a times b to the x, and the b is your common ratio, okay? So let's see. We know our a is where x equals 0, so that's this. So we have 0, 1/2, okay? That's our a value. And I've got a whole bunch of different points here, so let's just, let's pick a point. Let's do, let's say pick a point. It doesn't matter which one. I'm going to pick a nice one, so let's pick 2, 2. Okay, and I've got y equals a times b to the x. I've got I got a y that's 2. Okay, I've got an a that is 1/2. Okay, I have a b, I don't know yet, and raise it to the second power because my x is 2. Okay, I'm going to get rid of that that 1/2, so I'm going to multiply everything by 2. Get 4 equals b squared. I'm going to take the square root, and I get b equals 2. Okay, so I know that y equals 1/2, that's my a value, times b, which is 2, raised to the x power. And there's my exponential equation, okay, because there was a common ratio. So that's when you have an exponential. If we go over to b, let's see what we got here. I'm going to, again, always put them in a table of values. It's going to make your life a whole lot easier if you do that. So I'm going to have my x and my y. Let's see, make sure they're in ascending order. We've got -4, 1, -2, 2, 0, 3, 2, 4, and 4, 5. Okay, let's see what we got here. We are going up by 2's on our x value, adding 2 each time. Oh, and look at this. This is a nice one. +1 on each side, okay? So we have what I would call the difference, a common difference, right? So we know that this is going to be linear, okay? And your slope is your change in y over your change in x. So my change in y was 1, and my change in x was 2. I already put it there for you. My b, which is my y-intercept, is going to be, look, 0, 3. So my b is going to be 3. So that's easy. Y equals 1/2 x plus 3. So remember, when you know your explanation would be it's linear because you have a common difference of 1/2. Okay? So that's your explanation for that one. You have a common difference and it's 1/2. Okay? Let's flip to page 59. Okay? So we're on page 59. Let's go over to letter C. Okay? So again, I'm going to tell you every time, table of values, table of values, table of values. Okay? We've got our X and we've got our Y. I'm going to go ahead and I'm going to put those in ascending order. Go to 0, 1. You can do this on your side. Now, if you look, you can see that there's no common ratio, okay? This is being multiplied by times 1/2 times 2. Yeah, there's no common ratio, okay? So we're looking at either linear or quadratic. This one goes up by, plus 2, plus 2, plus 2, plus 2, okay? So there's that. That's not going to help me much. Let's look at this. This is minus 3, minus 1, minus 1. That's plus 3. Now, I want to tell you, this is your first difference. Okay? When you have something that's quadratic, you actually look to see if the second difference is constant. Okay? So our second difference, and I'll tell you what I mean by that. Second difference. Okay? Take the second set of numbers. That is plus 2. That was a positive 1. I messed up there. Sorry about that. Here is a positive 2. 1 to 3, positive 2. So our second difference, so we're going to say second difference is constant. Okay, and that's what tells you that it's quadratic. Okay, if your second difference, I can't spell, quadratic. Okay, that's what tells you if the ordered pairs are quadratic, if the second difference is constant. Okay, so you can see right here that you can see how it's symmetric, right? You go up and back by 2, 2. So this right here is going to be your vertex. So my vertex is 0, 1. Okay, and remember your vertex is h, k. Then I'm just going to pick a point. Doesn't matter which one. I'm going to pick 2, 2 because it's right there. So pick a point. I'm going to do 2, 2. Okay, and we are going to say y equals a times x minus h squared plus k. That's going to be the easiest way to get this into a quadratic form. Okay, so we've got 2, that's from my point, equals my a, which I don't know what my a is. That's what I'm looking for. I've got my x, which is 2, minus my h, which is 0, squared, plus 1, which is my k. Okay, I'm just going to bring this over a little bit over here. Okay, we've got 2 equals 2 squared is 4, so we've got 4a plus 1. Okay, I'm going to, I don't know why I put an a there, that's 2. Sorry about that. I'm going to subtract 1 from both sides. Okay, I get 1 equals 4a, divide by 4, I get a equals 1/4. So my quadratic equation is y equals 1/4 times x squared plus 1. Okay, because you're just putting it into this form. Okay, and that x is just like that because my h is 0. Okay, let's do another one. I think we could use another. Let's look at letter D. Okay, again, table of values. Let's switch colors so they don't all run together. This is a little tricky, but once you get the hang of it, it's not so bad. We've got an x, we've got a y. Okay, I've got negative 6, 0, got negative 4, negative 12, negative 3, negative 15, negative 1, negative 15, 0, negative 12, 1, negative 7, 2, 0. Okay? Now I can right away see that it's quadratic, but I'm gonna, did I miss a point? Negative 6, 0, negative 4, 12, negative 3, negative 15. I did. Darn it. Negative 2, negative 16. We'll write that in there. Negative 2, negative 16. Okay, and that's a negative there. Okay, so now let's look at our differences, okay? I like how these all go up by ones, right? Do you see this? Plus 1, plus, oh, hold on. Yep, plus 1, plus 1, plus 1. Those don't. This is going up by plus 2, plus 1, plus 1. So I'm going to look over here where they go up by plus 1s, okay? There's no common ratio. I can't see anything that's multiplied by that. So this one goes up by plus 1. Here's 16 to 15 plus 1. Here's plus 3. Here's plus 5. Here's plus 7. Okay? So that's not helping me much because I know that I'm not going to have something linear because they're all different. So let's try it again. Here I have plus 2, plus 2, plus 2. Okay, do you see how that keeps going up? Let me look here. Yeah, so that works. So it's going to be your second difference is constant, okay? And you can kind of see it, guys, when you look at it. I mean, you can see that you're going up by 1, back by 1, up by 2, back by 2, up by 3, back by 3. You can kind of see right away where it falls, and you can almost eyeball it and see that it's a quadratic without even doing the second difference, but I wanted to show you that. So it's quadratic. Okay, the vertex is the one I missed at first. It's negative 2, negative 16. Again, they're symmetrical, so you can see that that's the middle point and it keeps going up by the same amount, right? And back by the same amount. You can pick a point. It doesn't matter which one. Let's see which one we want to pick. Let's do any point. We'll do 0, negative 12. It doesn't matter. I'm just picking one. Okay, that looks like a nice one. There's your, I picked it because h is 0, really. And there's k. Okay, so y equals a times x minus h, quantity squared plus k. Okay, we're going to do y is negative 12 equals my a, which we don't know yet. Okay, we've got 0 plus 2, okay, squared, and negative negative 2, minus 16. Sorry, my dog is going all over the place and he's driving me crazy right now, so it's making me lose my train of thought. We've got Jack. Come here, Jack. Sorry, that's my dog. Okay, Jack, come here. Come here. Okay, we've got negative 12 equals, that's going to be 4, Jack, please, 4a minus 16. I'm going to add 16 to both sides, and I get 4a equals 4, so a equals 1, okay? And so then we're going to have our equation, which is y equals x plus 2, quantity squared, minus 16, okay? Because my a is 1. And if you wanted to multiply that out and put it in standard form, you absolutely could, okay? I think we're going to do just one more today, okay? And I'm going to go over to letter E, and I think that should give us enough for today. E, again, table of values, okay? We got our x, and we've got our y, okay? See, it would help if you could see. I've got negative 3 and 2 over 125. Oh, I don't like these numbers already. I've got negative 2, 2 over 25. I've got 0, 2, 250, 4, and 1250, okay? So let's look and see what we've got here. Here we are going up by 1, going up by 2, going up by 2, going up by 2, okay? Let's see what else we've got. It looks like we have a ratio here of times 25, right? That's what it looks like. I'm multiplying by 25, multiplying by 25, multiplying by 25, multiplying by 25, okay? So here we have to find out what our b value is. So we know that y equals a times b to the x. So this is going to be exponential, okay? And we've got, let's see, we've got an a value. That's where x is 0. So my a equals 2. I'm just going to pick a point. Let's pick 250. Okay, and we've got 50 equals 2 times b to the x. And my x here we said was 2. Okay, so that's 50 equals 2. I'm going to make sure my b looks better, squared. Divide by 2. We get 25 equals b squared. And b equals 5. Okay, so now you can go ahead and write this. Y equals 2 times 5 to the x, because 2 is my a, 5 is my b. We've got our x right here. Okay. You know I said we were done, but I think it wouldn't hurt us to do one more that is, let's see. Let's do one more that is quadratic. So let's turn to page 60. Let me look at these real quick and see if I can eyeball one that's, let's do C. C looks quadratic to me. It is. Okay. First of all, again, I can see right away, plus 2, and then I can already see where my vertex is, but we can go ahead and we can do our table of values like I said. Oh, don't need to, it's already done. Let's do plus 2, plus 2, plus 2, plus 2, and here we've got, let's see, 48, I believe. Here we've got, minus 48, apologize. There we've got minus 16. Here we've got plus 16. Here we've got plus 48, right? Okay, that's our first difference. Let's do our second difference. We've got negative 14 to negative 16 is plus 32. Here we've got plus 32. Plus 32. Look at that. Our second difference. We've got that common second difference, okay? Like we showed on this over here. Right here, we said that our second difference is constant, okay? So here we have a constant second difference. So it's quadratic. And you can see just right here where our vertex is. It's right there. My vertex is in the middle. So we've got 4, 6, and that's going to be H, K, okay? And then let's just pick an XY. I always like, or an XY. I like this one that has a 0. So I'm going to do 0, 70, but you could absolutely pick any of them. Okay, so we have Y equals A times X minus H squared plus K. I'm going to go ahead and fill in what I know. I've got my Y, which is 70. I've got my A. I've got my X, which is 0, minus my H, which is 4, plus 6. Okay? And now I'm just going to go ahead and I'm going to, let's see, I've got this right here. I've got 70 equals 16A plus 6, right? I'm going to subtract 6 from both sides. I get 16A equals 64. Divide by 16, you get A equals 4. Okay, so my equation, my quadratic equation is Y equals, I've got my A, which is 4, times X, my H is 4, so X minus 4 squared, plus my K. Okay, and there you have it. Okay, that's right at the 20-minute mark, and I think that's enough for today. Tomorrow you will be doing a quiz on quizzes. If you have any questions or have a hard time with the link, feel free to email me or G-chat me when I'm on tomorrow. Okay, take care.